In this video, we're going to learn about rotations in the coordinate plane. So rotations, remember, is when you turn a figure. So when we look at turning a figure in the coordinate plane, we are always going to assume that the angle that we're rotating is going to be in a counterclockwise direction. So I'm going to highlight that because that's important. The only time that you won't rotate in a counterclockwise direction is if the directions specify or if you see what a negative angle. So before I talk about that a little bit further, let's look at the notation. So capital R for rotation, it's very important that you keep it as a capital R because lowercase r is for reflection. So capital R for rotation. And then in the little subscript there, we have this coordinate is going to be the center of rotation. And if you don't see a center listed there, that means it's the origin. So if you don't see a center for some reason, it's just saying that we're rotating at the origin, which is the most common way that we'll rotate in the coordinate plane. And then the symbol there, right here, this is called theta. So this symbol is called theta. And this is the angle of rotation. So this is going to tell us how many degrees. So when we rotate, like I said, we're always going to rotate counterclockwise unless it's otherwise noted. So counterclockwise, going against the direction of the clock, you can abbreviate this as CCW. These are always going to be positive angles. So for example, if I see something like this, a rotation of, so let's just say it's 0, 0 of the origin, and then I see a positive 90 degrees. That means that I'm going to rotate 90 degrees. So this is 90 degrees counterclockwise. So these are always going to be positive angles. Now, if I see a rotation of negative 90, so let's write that as an example. Let's just do this over here. So if I say a rotation of negative 90, notice that I didn't put the origin because, like I said, if you don't see 0, 0, it's really assumed to be there. So in this example, my center is still 0, 0, 0, even though I don't see it. But if I had a different center point like 1, 2, well, then you'd have to write it. So I just want to show you both ways. So this would mean 90 degrees clockwise because it's a negative angle. So what can happen, so let's just write this. So CW for clockwise, and these are going to be negative angles. So in your directions, when you go to rotate, you might see a negative, like using the symbolic form, you might see rotate negative 90. Well, that means you're going to rotate clockwise, or the directions just might be in words. It might just say rotate 90 degrees clockwise, which basically means, okay, it otherwise noted to tell us to go clockwise. So those are your different ways to represent clockwise. If it's positive, if it doesn't specify, we're always assuming counterclockwise. So let's actually try some examples here. So when I look at this first one, we have point P. So let's go ahead and start with point P. So 4, negative 3. So there's point P. And I'm just going to have to bear with me here with this because I want to lock this in place because I'm going to, when we rotate, what's going to end up happening is we are going to turn our paper. So I want to be able to show you that. So just bear with me here on the computer. So for part A, I want to find P prime, the image of point P, after this rotation centered at 0, 0, 180 degrees. So what I want you to think about is where would 180 degrees end up? So when we look at our graph, our 4 quadrants here, each one of these quadrants represents 90 degrees, right? There's 4 right angles. So 180 really means 2 times 90, right? 2 times 90 equals 180. So whenever you're rotating 180 degrees, what you're going to do is you're going to turn your paper 2 turns. So this means I'm going to take my paper and I'm going to rotate my paper 2 times because 2 times 90 is going to give me 180. So I'm going to rotate. So this point P should end up moving 2 quadrants, right? Because if I take this and I rotate it 90 degrees, that would move it to this quadrant. If I rotate 1 more quadrant, it would end up over here, which is 180 degrees. So that's where I'm expecting it to go. So what I'm going to do is I'm going to take the top of my paper, and remember, it says positive, so this is 2 turns counterclockwise. So I'm going to take my paper and I'm going to turn it left or counterclockwise. So there's 1 turn. This would be 90. And now I'm going to do 1 more turn, and that's 180. So essentially, you turned your paper upside down, right? Because 180 degrees, turn it upside down. So now I pretend that what I see here, so I pretend that this is my new x-axis. So I'm going to erase this, but just so you can see, this is my new x, this is my new y. And what I do is I ignore all these numbers and I pretend, so if this is x and this is y, I'm going to count, well, where is this point located? Because remember we said it was going to end up in this top left quadrant. So this is now located at 1, 2, 3, 4, so -4 up 1, 2, 3. So let me erase that. I don't want those. Oops, I'm just going to do this. So this is at -4. So point P prime, -4, 3. That's where it needs to end up. So now what I'm going to do is I'm going to take my paper and I'm going to turn it back over. And I'm going to plot that point. Those are the coordinates. That's where this should end up. Remember, we said it should end up over here. So now I can go ahead and I can write -4 up 3. And I can label that as P prime. Also, the connection I want you to make here is the center of rotation was the origin. So what that means is we took this point, so this distance right here to point P. If you rotate that 180 degrees, so here's your straight line, you get P prime. So that's kind of cool. You see the 180 degree angle. I'm going to erase this because it's going to make my picture crowded. But that distance from the center of rotation should be the same, and that angle should be 180 degrees. So that's pretty cool because now you can see that connection. So I'm going to get rid of that just for the sake of my picture getting too complicated. So there's that one. So now what I'm going to do is I'm going to find P double prime, which is the image of point P. So notice we're going back to point P after a rotation of 90 degrees. So I want to lock this one in place too because I just want it to all stay together here. So I'm using the result. So I'm using the original and I'm going 90 degrees. So think about 90 degrees. Well, this means I would have to move 1 quadrant, right? We're going counterclockwise again. So this means we're going to turn our paper once. So 1 turn counterclockwise. So it should end up here in quadrant 1 because you're rotating it just 90 degrees. So basically, if you imagine like a right angle right here, that same distance away is where it should go. So I'm going to take my paper, top of my paper, I'm going to turn it left or counterclockwise 1 turn. And now I'm looking for the image of point P. So remember we said, here's my new x-axis, here's my new y-axis. We said that point P double prime, or the image of P, should be in quadrant 1, which I can see that's where it is. So I'm going to copy down those coordinates. So P double prime is going to be, it looks like over 3, 1, 2, 3, and then up 1, 2, 3, 4. So there's my coordinates for P double prime. Rotate our paper back, and now I can plot it. So P double prime is going to be 1, 2, 3, up 4. And again, if you imagine, okay, well, that was centered at the origin. So if you imagine this distance, that distance looks the same. And see how it looks like a 90-degree angle? That's good to go. That means I did this correctly. So let's, and again, I'm just going to erase that for the sake of not overcrowding our picture here. So there's that one. The last one here that we're going to find is P triple prime, which again is the image of point P. So it means we're starting with point P again. And now we're trying to turn this 270 degrees around the origin. So again, same rules apply. So 270, think about how many times you'd have to multiply 90 to get 270. Well, 90 times 3 is going to give us 270. So this would mean 3 turns, and again, counterclockwise because it's a positive 270. So think about it and how many quadrants it's going to move. It's going to have to move 3 quadrants because 1 turn is equal to 1 quadrant or 90 degrees. So 3 quadrants. So if I think about the location of P triple prime, so start at P, it would have to go 1, 2, 3. So I'm expecting it to end up down here to get 270 degrees. So when I take my paper, I don't remember if I grouped this or not, so let me just group it quick. So I am going to take my paper and I'm going to turn it 3 times counterclockwise. 1, 2, I'm at 180, 3, there's 270. So here's my X, here's my Y. Remember what I said, I expected that point P to end up in quadrant 3, right? 1, 2, 3. I expected it to end up down here. So now I want to read those quadrants or those coordinates where they're where it's located. So it looks like I went left 1, 2, 3. So let's write this up down. So P triple prime is going to be left 3, so negative 3, and then down at 4, 1, 2, 3, 4, so negative 3, negative 4. Let's rotate this back. And let's plot those points. So negative 3, negative 4. Here's P triple prime. And again, if you imagine here's the center, here's my angle, right? That distance has to stay the same. This angle is 270 degrees. So that one you might want to draw in just because it's the last one that we're going to look at. So that's, you're rotating. So rotating 270 degrees, let me write that in black so you can see it. So 270 degrees counterclockwise. Notice that if I would have went this way, clockwise, how many degrees would have been, how many degrees would I have rotated then? Well, that looks like a 90-degree angle. In total, 360 degrees, if you subtract off 270, you're left with 90. So this would be 90 degrees clockwise. So whenever you rotate 270 degrees counterclockwise, that's the same thing as doing 90 degrees clockwise, and vice versa. So if I rotated 90 degrees counterclockwise, that's the same thing as doing 270 clockwise. So what that really means is this, oops, I just noticed there's a typo here. This should have just said capital R, right, because it's a rotation. But this is the same as a rotation centered at 0, 0 of negative 90, because negative 90 means 90 degrees clockwise. So that's kind of cool. So then what I could have done is I could have done 1 turn and I would have turned my paper clockwise 1 turn and you would have gotten the exact same answer. But that's why I like kind of sketching in that angle. So that's it for this video. So I want you to go ahead and write down some key ideas if you have any things that you want to remember, and then do the check your understanding problems, and we will talk about those in class tomorrow.